Hello guys, welcome to my channel. In today's video I am going to show you how you can develop your next robotics project in ROS without installing ROS in your local OS. So first, the question that comes up in your mind is why would you want to use ROS without installing it? One of the major reasons for wanting to do that is that installing ROS is quite difficult, and ROS takes up quite a lot of time to install it properly in the first try, as it involves quite a number of steps. So after your first installation, if it encounters some problems, then you might have to redo the entire process again, thus losing a lot of productive hours. The second reason for not installing ROS is if you are a developer, is that if you are developing on Windows, then ROS 1 supports only experimental installation, which means if something goes wrong during the installation, you might have to search through a lot of solutions and read a lot of questionnaires on the ROS answers blog and then find the solution to your exact problem, which in some cases might not be available as well. And I can show you the website with the number of steps required for installing ROS on Windows, and as you can see there are almost 7 steps, yes, and they take a lot of time to be installed properly to make the installation correct in the first try as well. The third reason is if you are working in a team of developers, it's very difficult to maintain all the packages at the same version for all the developers, because not all the developers are working on the same topic or on the same project at the same time. So if you are uploading your code, let's say for one version of ROS or one version of Robot, another developer in your team might not have the same installation on their computer. So with Docker containers, it makes it very easy to share not only your code but also your running environment, thus ensuring that your code works everywhere and not just on your PC. The fourth reason is if you are developing software for multiple robotic platforms, chances are that you might have to work with different versions of ROS. Developing in Docker will ensure that you can seamlessly transition between different ROS versions just by starting up a new Docker instance. So while searching for better alternatives to installing ROS natively on your OS, I came across a solution using Docker. Now in this video I'll not talk about what Docker is and how it works, but if you guys are interested, I'll make a separate video about it. Do let me know in the comments below. The first step in installing VS Code and Docker Desktop is you have to install VS Code and Docker Desktop. If you don't already have them installed, then please start downloading them and then install them on your system before beginning with the steps. Once installed, the next step is to open VS Code and click on the bottom left corner or press F1. So you can either click here or you can just press F1 on your keyboard. So once that is done, you will see there are a list of options that come up, and for you or for your case this might not be the first option. So what you can type is just type in container and you should get an option out of these 5 options. So for the first step, what we need to do is we need to click on open folder in container, and for me I've already created this folder, but you can create your own project folder and click on open, and then you will get a list of all the configurations that are required. Because for our case we'll be using a ROS configuration setup, so you can just select any configuration because that will not be important, as you'll be changing the final ROS Docker file and the dev container file. So what I will do is just scroll down at the bottom and select Ubuntu, and you can just select Ubuntu 20 and then click on OK. So once you do that, you should get a small window here saying starting dev container, and we can click on show log to see what steps are being done in the Docker container and how your installation is taking place. So as you can see, now the installation is complete, and we can just click on this terminal here to open our bash terminal. So this is a standard Ubuntu terminal, and we can just type any Ubuntu command like ls. Yeah, we do not have any files, so we can just go back cd, maybe one more level, and then just type ls. As you can see, these are the standard file system of Ubuntu. So once you are done, you can just click on this dev container tab here, and you'll have two files inside your folder, inside your dev container folder. The first one will be the Docker file, and the second one will be the dev container.json file. Now the Docker file is the actual Docker setup file which will install your Docker setup environment, and your dev container.json file will specify the various kind of configurations that this Docker file will be adding. So the first thing that we need to look at is the Docker file, and the first line of code that we'll be looking at is this: from osrf /ros noetic desktop focal. So what this line means is that we are downloading the ROS's official Docker image from the Docker repository. So Docker maintains a repository just like GitHub, but it is not for your Git repositories, rather for Docker images instead. So with this image, we will not only install ROS, but a version of Ubuntu as well. And because we are installing ROS Noetic, so the version of Ubuntu that will be required for this version of ROS is Ubuntu Focal, which is Ubuntu 20. Once that is done, we'll be updating our Ubuntu using the apt-get update and the apt-get install commands, and we'll be also installing our OpenSSH client. The final step is we'll be sourcing our bash RC script, which is a critical step in the ROS installation. Now coming to our dev container.json file, so here we can specify the properties of the Docker file as well as the installation. So first we have the name, which is ROS Noetic dev, that is our ROS version. Then you have the Docker file. So in our case, this is the name of the Docker file that is doing our Docker installation, which is present in this folder. And next comes the VS Code extensions. So these extensions are really handy for any software development work that you do in VS Code, and you can install any extension available in VS Code. The following run args are required for and during the installation process. And finally, in the settings, we have to set it to the bin bash so that the container starts on the bin bash once it's finished building. Now I'll just add the Docker file and the Docker container.json to my GitHub repository, and I'll have the link in the comments below, and you can just click on that GitHub repository and just download the code for your own use. This is just for explanation. So once you have your Docker file and dev container.json in this exact specific conditions, what you can do is again press F1 or click on this bottom left corner here. So I'll just press F1 and then just click on rebuild container. In your case, it will not be rebuild, it will be build containers because you'll be building it for the first time. So, but in my case, I'll just click on rebuild container, and then like last time, we'll see that it's starting a dev container show log command, and here you can see all the installation taking place. So you just have to wait for some time before the installation is finished. Now once it's finished building, you should see a terminal like this, which will have a root keyword in front of the name, and then some funny numbers and combination of numbers and letters which are from the Docker itself, and then you will have your workspace and ROS Docker folder. So your ROS Docker folder is the folder on your local PC in which you are storing your files, for example your C++ files and your Python scripts with which you are developing your robotics project. Then once it's finished building, we can verify whether ROS was installed correctly. So the first command we'll be testing is ROS cd to check our setup.bash file path. So you should get a path which looks like this: opt ROS noetic. We can just type pwd to verify the final path. Yes, we get opt ROS noetic. And then the next verification that we'll be doing is we'll just start ROS core. So once we enter ROS core and press enter, our ROS master should start, and we can open a new bash window, and here we can just type ROS node list to see the nodes that are currently active in our ROS core, and in this case it should be ROS out only. So that's it. Now we are completely set up with our ROS environment and we are ready to directly write software in this.